unacceptable. Actually, I don't think we're having math class next Friday because it's Veterans Day. When we observe Veterans Day. At least I'm fairly certain. Let me double check.
Wait, what are we observing? Leadership training.
Yeah, so that will be fun. I don't think you'll miss
Oh
it.
no. Civil War. I'm hoping to get at least $60 this year for theater fair. I need the money. I have like no money.
What are you selling?
I have like 60. I don't know.
Well, I'm hoping to get $60. I have no idea what I'm going to sell. All right, hey, before we move on, flip to the very end of yesterday. We never got to talk about 27, and we need to give it at least a moment of our time.
Oh my god.
I did not forget. It's okay if you do. It's my job to remember.
The homework
Can it be my job too?
Homework is fun. I like these problems.
Very good.
Tonight's homework?
Tonight's homework isn't that bad.
It's factoring, as long as you get the hang of what you're doing. You know the difference between just factoring what we did yesterday and factoring completely, yes?
Sure.
Chris, Ryan, maybe, yeah. When you have an extra term out in front of your binomials. So after we get through the lesson, you might want to check if did we do this completely correctly. So finishing, now I'd like your focus, please, gentlemen. Finishing from yesterday, we see a. Are we good for doing this now?
There's a civil war going on.
It kind of is a civil
At least
war.
it's civil.
It's between
They're
the
being
little.
I don't care
They're
about that. I
being rude.
push my desk towards that. Okay?
It's very stupid.
I'm saying
Please
stop.
help.
Just stop putting
It's
this
very
on my
expensive.
desk.
You guys can commandeer more desks if you need. So again, Colin. Actually, if you guys want to move there, Colin needs more space. That is a solution. But again, Colin, if you need more space, that's fine, but you can't take up somebody else's space because that will negatively impact them. So check out 27. We have 2 of the dimensions here, and we are missing 2 of the dimensions. But because we have 2 of the areas, we'll be able to solve the rest of it. Let's look at this top left box. When we look at multiplying x minus 2 times x plus 7,
Can I make one point that I'm pretty sure of that
Okay.
knows about this? It's probably gonna be pretty major, but
pretty major. Sweet. Did I slip it?
this area model actually appears to be an area model with each square comprised of an area.
Correct.
It's basically a composite area
It's
model.
an area model of areas.
Area model inception.
It's an area hot.
Area inception. All right. So if you want to do the what we've already spoiled a spoil process in an easy manner, set up another rectangle to do the binomial multiplication. Now I just made it a square, but we get x squared, negative 2x, 7x, and negative 14. So please do the work to catch up to me. We're on 427.
I have
This-
a joke now.
Save it. We wasted a few minutes already. Sum your like terms, your x's, so 7x and negative 2x will sum to a 5x, and fill in that area, or really just that trinomial, in the correct location. Are we going to do what? Yeah, it's Worthington. All math courses, 6th grade and up, have adopted CPM now.
No, fifth grade did it. Fifth grade. I think fifth grade was
Not
He was
that I
talking
know
to
of,
somebody in our advisory box.
Oh, wait, never mind.
I could be wrong. I've been wrong many times before.
Yeah, okay, yeah, just, yeah, good enough. I was gonna say no, the fifth grade is doing it too, but
I'm actually
I
hoping that
me
Mr.
an
Hall's
EP
right
class and
now.
they were all advanced here.
So then over here, we have to figure out the factored form of 3x squared minus 5x minus 2 when we know that one of the factors is x minus 2. So what do we know right off the bat?
There's
Well-
an X
It's gonna be a
in
five.
the other one. In the second binomial. There's an X.
More than that.
5
And a 1.
and x squared.
Ah, that erased
There's
a lot.
another x that's x minus 2. 3.
Wait, what?
3.
a 3x. My smart board. It's in some spots it's off and in some spots it's right. So then we could think about the first and the inners, right? Because we have the firsts and we have the inners. So right now these, or this multiplication, would give us negative 6x. So we need a positive 1x. So here has to be a plus 1. So this would be 3x plus 1. Okay, why? So,
Oh, I see. Okay.
well, so for here, we're going to approach it a different way. Okay, so using the method from yesterday, we would say, we'd probably put it down here, 6x squared and 1. And we know the sum of these will have to be 5x. But when we look at the product, like the cross product, we get just 6x squared. So we know that when we set that up, and we actually already know part of the other, we know one of the other dimensions. Here we know that one of the dimensions is 3x plus 1, so one of my x's has to be 3x. We've already got that. The other one's got to be 2x. So now we know it's 2x. Okay. 2x what? There's got to be a constant with it, right? So we now are working with 3x plus 1, 2x, something else.
Plus 1.
How'd you know that?
Because the 1 times the other number would have to equal 1.
Yeah, and the 5x,
Yeah.
the sum of 5x and the product of 1. You kind of look at both of those at the same time. You say, okay, I have to multiply to make 1, and does that work to make my 5x? It does. And then we can fill in right here. Fill in right there. Take a moment, try to do it on your own. What is in that top right box?
27.
27.
No, actually it's 28.
I did this wrong. You spoiled kids.
Or set up an area rectangle.
Well, then he taught me to use field.
I actually have to do the joke for your house.
He's like, first and under that.
I would really advise, for ease of writing it, just do the rectangle. Even if you understand FOIL, which hopefully we're starting to get, it's expanded distribution, but this is just cleaner. And then if we can do this mentally, we get here, whoever has it, we
I
get,
have it.
just say it.
2x squared plus 15x plus 7.
I was about to say, I didn't know we were racing.
I
27.
just talk fast.
Now, somebody also, because they were speaking fast, I'm getting that. Somebody said 2x plus, they forgot the squared. Be very careful. It's not a race. Be precise. So that ends our work from yesterday. So let's flip over to 414 then. Now, this goes back to something that we really could have potentially noticed yesterday about getting multiple factorizations of an expression. So, try these 4 expressions. Try factoring those. See how good we're getting? Whatever method you want to take.
Are we gonna
Just-
use the crisscross method?
Whatever method you want to take. At your table, check with each other once you start getting them. Take a few minutes. Try to factor those situations.
Well, you don't have to do that. Useless without the squares.
Yeah.
No, like, seriously.
Dude, you can draw a square.
I know, I just think.
All right, let's back up. Hold on.
Okay.
Because I think we're conceptually forgetting about something. When we draw the squares, and the reason CPM does it how they do it, and this is why I've succumbed to the putting the heavier on the bottom.
Wait, why is that heavier?
It's got a higher exponent, so it's got a larger value, like when we talk about certain things. I like to put it top left, but because of CPM, I've now changed my ways. The reason that we do this when we go to that rectangle relates back to the visual algebra tiles. Do we remember why exactly that is? Exactly. So let's revisit this for a minute. If you would like your own algebra tiles to play with, if we don't make it through this lesson today and just finish it tomorrow and wrap there, that's fine. But if you want your own algebra tiles, grab them. Or who wants them? Anybody? Algebra tiles, play with.
Nobody likes them.
Well, you're going to have to work with me then, because I'm not just going to give it to you.
You're accelerated 7 and 1 is 8.
Whoa, calm your horses.
Wow. Why would you do that?
Those are bigger problems. A lot of them have multi-parts. It's that whole our homework's full of problems. Everyone has A through E.
Yeah, that's the only thing with CPM.
Hey, but they're grouping the related problems, so it's not like you have 20 problems that are all the same. All right, so 9x squared plus 4. When we start that rectangle thing, it would be like that. But why? Why are we building it like that? Goes back to actually the visual. This is going to be tough to need 9x tiles.
Wow.
Well, x squared tiles more so. So we are trying to find, well actually, who can tell me what we're doing with factoring? Why we're factoring, what we're doing with tiles. I'm going to put this up on the TV, so if you're watching the video, you're going to get the short straw right now. But
Are we gonna watch it?
no, I'll put it down here, I guess. You guys have this, right? 9x squared minus 12x plus 4, right? That's what we're solving. I'll even take a snapshot of it so it's up on the TV. Let's just do that. That'll be easy. So here's my 9x squareds, right? But then it's minus 12x plus 4. Negative 12x plus 4. That's really quite awkward. Right? How would I model that visually? Well, Colin?
Use the X tiles, but flip them to the negative side.
Ah, so I'm going to take away x's. This is like saying if I were able to make a rectangle. Right, so here's my 9x. I can keep that as a square. I can move some around. Like I could bump some down here and leave some up here. I could do a lot of things. But then if I flip my x tiles to the negative side, do I put them beside or on, or what do I do with them?
Okay, what do the negative tiles look like? They're the same thing.
Same tile, red.
That's so weird.
There's two different sets, and depending on which set you grab, depends on which colors you've seen. We have not gotten very specific with modeling this yet. I just wanted to bring us back to something. Let's do an easier one really quick to show the visual and the why.
81m squared.
Yeah.
So x squared plus 6x plus 9.
You need 81m squared.
Hold up.
Oh, you got that.
Hey,
Hold up.
hey, people. Why did we all start talking? If we go to model x squared plus 6x plus 9, and if it's factorable, that means that we can make a perfect rectangle from an x squared 6 X tiles and 9 individual tiles. Now I have sets of 5 tiles put together. If you are able to use that somewhere. Well, no, those are just if I want 5 that move together. So I have to try to build a rectangle, right? So if I put all of these out here, and then, well, no, that's not going to work because now these, well, crap, my X never lines up countable. So since my X is never countable, when we start to work with this, we normally should try to put another X tile on the edge of the X squared because it's not countable, right? We don't know what that quantity is. Okay.
You're gonna want individual movement in each of them.
1, 2, 3, 4, 5,
7.
Oh, I know this looks like 7, 8, 9, yes,
6.
1, 2, 3, 4, 5, 7, 9.
Yes, Colin.
7, 8.
1, 2, 3, 4, 5, 7, 9, 6, 8.
What?
Yeah.
Don't forget
So-
11 and 7.
So hold on. Crap. This won't shoot. That doesn't work.
Oh, wait. Do you
I gotta.
Ava?
take one of the X tiles off on the bottom, move it on top, and then make another row?
If I make another row,
Nope.
Oh wait.
One
this was
more.
another X to the top and then
Yeah,
make it 9 by 9.
3 by 5. You get 9 by 9 equal 9.
Colin, you're being a little bit rude today, bud.
Whoa.
So, through a little bit of playing, I got to this point. Sorry that my screen is so dark.
Why?
I'll tell you later.
Whoa.
Actually,
That looks so cool.
that rectangle thing is the actual built area.
Well,
I want to try
Cool.
that.
You
I
can
know
rotate
if I
it and
should
then it's the
do
same.
it properly.
Oh,
Can you use what? What do you mean that?
Guess what? I can pick them.
I mean, it's hard. It's actually harder to figure it out. Well, it depends on if you're more visual spatial or if you're more mathematical. But any of these. So hold on. Let's see if we're working together. And I don't know how I can.
Whoa. That was magical.
Let's clear ink.
That looks cool.
That looks pretty lit. Get it?
So up on the TV, 2x squared, right? So I need 2x squared and 5 x's, so 3, 4, 5, and 3 constants. How do I build a rectangle?
Yes.
Okay, so first of all, we need to get some stuff.
Oh,
Whoa.
Jenny,
there's
here's
like-
Where should I immediately, Ethan?
1x on top of each of the x squared. Put the 3 x's on the side, pretty much like the
Oh, yeah.
and then the
Good
constants just
What's the factored form of 2x squared plus 5x plus 3? Yeah, 2x plus, how wide is it?
5x plus 3.
5x
plus what?
How wide is my rectangle?
Oh, we're talking 2x squared plus 2x plus
2x plus 3, length, right? Length can't be squared. X plus 1. The factored form.
3 and 1.
Now, as you're doing your homework, you can access digital algebra tiles and just play with them in an area. So if you go to the homework help or the digital textbook, you will eventually, in the blue text clickable, can get to, actually it might be in this homework help. You can get to actual algebra tiles.
You should show us.
Let's just assume x is 0.
Always 0.
I mean, you could probably even just Google,
What does x equal?
hey guys, Can we like try to focus a little bit? I was trying to ignore it and let it correct itself, but you're not. So now it's becoming slightly annoying because you're impacting class. So if you search like CPM algebra tiles tool,
Wow, this is loads.
hey, we're on school internet. There you go. Algebra tiles.
That's cute.
You drag them in. Use whatever you want. If you double click it, it will rotate.
Wait,
You click it once, it will flip to the negative. Double click it, it will rotate.
That's pretty
Please excuse this interruption. Could I get Zion Scott to the office?
You
Zion?
All right.
Hold on, question.
Yes.
Does it look like those aren't those look like rectangles, not squares?
Colin, you're on a TV being stretched a different direction depending on how we drag it. You're being very, very critical about something that doesn't matter because it's a variable. I love your preciseness, but sometimes it's unnecessary, buddy.
It's not drawing the scale.
Unnecessary.
All right, close, back to today.
Tomorrow.
So, we will, at some point, pull back out the tiles. Maybe tomorrow we just will play with tiles the whole time. But like we said when we first started approaching that, but then we were going to just be using a lot of tiles, this would be that our rectangle is missing that much dimension, or that somehow the product becomes negative. So if I have to sum... Oh yeah. Especially like D, you could totally solve the algebra tiles. So somebody help me again. If I have a negative sum and a positive product,
Well, then both the numbers have to be negative.
Yes. Both the numbers have to be negative. Okay, so what numbers do I get here then?
You get
Are you rolling with it or no?
what?
Do you these or these?
Oh, yeah.
whatever. Yeah, Jen.
34, right? Okay, yeah. So we get 3x minus 2 squared. So
I'm just writing to catch up with you. So you said 3x,
minus 2.
3x. This is minus 2.
The other one's minus
And okay. So wait, they're the same thing. So we could write this
3x minus 2 squared.
3x minus 2 squared, which we then know that we could make this as a perfect square, not just a rectangle for the area, but a square. Now, can you visualize, I'm trying not to give you too much, can you visualize how that whole negative 12x might come into play if we go back to how I had tried to start with the 9x squares? Four positives. How in the world does negative 12x play in here? Ethan?
You put basic. You put one on each of like the side planes. I can't explain it.
Can you come show it?
Yeah.
Do it.
Wait, no, that's a lot. These are X's. Okay.
Now hold on, before you put the x's in, can you tell me what to do with the 4?
4.
So you guys just told me the dimensions are 3x. minus 2, right? Then we have a positive 4. This is A. We're just taking a while to talk about it.
Okay.
You're good. So go ahead and put the X's. Then I think the 4 will kind of show itself. You need a better light for my desk. Sorry, guys.
Now the dimension, length and width, is 3x and 2 negative values of 1 for each dimension. And then those 4 are literal area values, 4 squares that are hiding up in the top corner, but they're positive. They exist. The x's are negative values, like the anti-x. Does this make a bit more sense now? For when we find the factored form, it's the dimensions.
We'll probably just play without it.
Okay.
Would that work? We
Yeah,
just
that
play
actually
without
makes
it.
sense to me. Oh, interesting.
You just what?
You have stuff like that. You can, this is probably a really stupid thing I realized, but you can basically see it as the colored side's like 3x, and then like minus the amount that's in the red tiles.
Yeah,
It's like,
yeah.
It's like written out visually.
Yep. And B, because it's missing the middle. Now, I could go through all my bags and probably get out 81 m squares. But if we visualize like we just did, how do we get no middle term?
Oh, you get 0 because it's always following the a squared plus b at 9x and negative 9x.
Okay, so you said, well, it can't be 9x and negative 9x, so I have to make a positive 81. And really it's m. But
It's 9m and another 9m. And then the next two constants.
It's 9m plus 1 minus plus times
Negative
nine.
nine.
Wait.
Is it
Plus 1 is just negative 1.
Yeah.
It is negative 1 plus 1
Plus negative
equals
1.
0.
Zero.
think about the fact that the middle term is always the combination of those two parts, right? The bottom right of the rectangle and the top left of the rectangle, which I guess from your perspective would be this. But if you think about, we have 81 m squared tucked in here. Then up here, there's some amount. Down here, there's some amount. One of these is positive and one of these is negative, and they're equal sides. How big they are is determined by that product of the outer inner. They would each have 9 of the m tiles, one of them positive, one of them negative. And then, in the very corner, you have a negative 1. Preguntas. Questions?
See, I can't Spanish.
Okay.
Do a good.
Now, try D. Have we gotten D?
I did.
I want you to compare with your table group, and if your table group all has the same answer, jump to a different table group and see what they have.
I'm gonna jump to your group.
Jenny, I hope you guys want to
Jenny,
I did it out.
Yes.
I got 3 plus 3. I have 3 plus 3.
What? Okay. I don't know what you're doing.
Nope, you can't leave. Because you got the
These numbers need to cross. Better than your silly. And leave your silly behind.
Not actually true.
What kind of special graph paper will Roxy?
What are some numbers?
What? Yeah. Oh,
Very
you
low.
Let me see what
Well, I just do realize that I can tell you. It's not.
Wait, how's that?
Yeah.
Wait.
What'd you guys get for B?
3 plus
Oh,
1.
what'd you get for C?
3 plus
Once
6.
you're done, we can compare.
Let me see. For D, I got 3 plus 6 times.
I was deliberately not listening.
Yeah, that's what I got.
That is
You got
That's not
That
nice,
works.
Tom. I
I've
stated
seen
it
it.
not
So
listening.
this would be 3.
That's what we.
Yeah, that would work.
I think what you mean to say is different. By saying wrong, you're making a judgment call. Alright, bring it back for a second. Who got the factored form to be... You don't raise your hand yet. You don't know where that sentence is going. To be 3n plus 6 times n plus 1. Who got that factored form? Now, if you then told somebody who got something else that they were wrong, you yourself are wrong. Now, your factored form is right, but it's not the only one. Because if I move these, boom, 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 and I move these, boom, 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 I can now get a different factor form of the same area with different dimensions. Why do we think this happens?
Because they all are divisible by 3. Do you have a common factor? But
So wait. So stop. You guys keep taking things too far. Like, I have a 7th grade class that I kind of expect that out of because they don't have frontal lobe developed yet and they don't think about their decisions. But I feel like I take a step into like loose direction and we take it too far. We're like talking in weird voices. We're applauding when we shouldn't be. Like, come on, guys. Visually, how does that common factor of 3 come into play? Owen?
All of the things are in sets of 3, so the x squares are in a set of 3. Like, I have them organized in sets of 3.
So wait, so sets of 3, so split into 3, 3. So there's 3 groups. There and here. And okay, so there's 3 groups of what we have.
3 equal groups. You could make them all into squares.
So you can just make 3 and little.
So what do you actually have here? Colin?
You have 3 small area models that can be combined into a larger single one.
How would we write that out? So we just said we have 3 of the same area model, but each of these area models is still a binomial times a binomial, right? So the small area models, what's the, width? Anyway, I'm just, x plus 2. What's the length?
X plus 1.
We have 3 of this set. Now, some people will argue here, we need a big old parentheses around here, right? Well, if I distribute 3 into here, and then I multiply to my other binomial, that 3 will carry through, right? So
That's all I was confused on how to do that. I thought you distributed 3 to also be x plus 1.
it will when you do that multiplication, yeah. Because otherwise you multiply these together first, and then apply the 3, so it comes down to what order do you do it in. You'll do it the same whichever order you do it. Yeah.
I just looked at my different notes, pointed out why that also works. Because, and this is probably, is maybe what you just explained in a different way of saying it, but wait, does anyone not have the sidelines yet?
We just talked, yeah, we just figured it out.
So, sidelines are 3n plus 6 and n plus 1.
But that's not all the way factored.
That is.
So, now the last thing I was going to show is if you have a rectangle and you know you have 3 of them, I'm going to come back to you, Colin, I promise. I can literally just stack either beside or on top of, and this gets a little bit more awkward than how we normally build them. But if you know you have 1, 2, 3 of the same thing, now hold on. Colin, again, what'd you say the side lengths were?
The side lengths that I got for it were 3n plus 6 and n plus 1. Which
So to make that, I could move this line up on top, right? Because each of them can go kaboom.
Yeah.
You guys don't Tetris enough. That's where the booms come from. Tetris. When you stack it down and make a row, it like boom disappears. So I could move all of those up, and that's how Colin can get us 3n plus 6 times the n plus 1. Or if we keep it like this, it's 3n plus 3 times n plus 2. Notice all the different ways this can be factored, because we should really pull the common factor out first. Say, I don't want to build 3 of them. I don't want to use that many tiles. Divide the whole thing by whatever we can. Wipe all these out and work with a little guy. So, moving on. Taking way too long for this.
Yeah, it's literally a few pieces.
So, check out I through Ivy. Check out these. Which of these should have more than one factor form? What would be the first step of getting into the final factor form? So I'm kind of going rogue from their question, but if you look at these, which of these can you quickly tell would have multiple factorizations, and how do we get to the final factor?
What?
I did my team.
You get I and I.
Really? No.
So I think we can all quickly see that in I we can divide by 2. So pull that out. 2 out in front of, what does our trinomial become?
6t squared minus 5t plus 1. Oh, I'm so smart. I'm really
Then, doesn't make any sense, it's not a common factor. If we split these into the binomials, we know that we'll either have to have 1 and 1 or -1 and -1. We know that to get the 6t squared, we have to have positive times positive or negative times negative. And to get the -5t, we know that either I have to have one positive, one negative, with the negative more powerful, or both negatives. Anyone know it? Sometimes you can just like kind of see it. It just comes to you. Ethan?
-3t plus 1. Wait. Yeah. -1. No, plus 1. Wait.
So if you do that, it'd have to be this, right? Sorry, that would have to be plus, yeah. Does that work? Positive 6t squared, -3t, -2t, positive 1. Now, would it also work if we did this? One would make more sense, especially if we tried to number. Here's the only difference. Your factorization of the negative. I mean, they're the same thing, essentially. It's like multiplying by -1.
You write less in the top one.
I wrote less?
Yeah.
What do you mean?
You don't have to write as much as the top one.
Okay. I guess that's the difference.
Yeah.
There's less effort involved. What other one can be quickly factorized? Or,
The third one.
yeah, the third one. By what?
5.
5, so that would become 5 times
2x
Plus 5.
-3.
ooh, that -3. That constricts things a little bit. Because to get that -3, we have limited options. It's prime. That's actually nice. It helps our situation be easier to solve. Try to factor that out completely. I'll give you a second.
That is more than the second. Too late, guys. No.
Wait, nope, just kidding.
Yeah, I was waiting.
Chris?
2x plus 3.
So my first step would be that, right? We know that has to happen. Then you went ahead and threw a 3 there, so that meant this had to be a -1. That doesn't work.
Oh wait, no, I had it in my
So hold up, check this out. Don't write anything right this moment.
Nope.
This works until you try to make the 5x.
Yeah, I had the regular.
So now, do we just change the 3, make that the negative, and put that over there, or what all needs to change?
Swap the 3, positive 3 and the negative 1.
So the whole include, come
What a
on.
prank.
It doesn't want to, unless I like rub it, it doesn't.
Even when you rub it.
It has to be flat, so it's a multi-touch screen. This is mathy. If you only touch with one point, it still thinks it's the pen. So even if I pick up the eraser and touch with one, yeah, my smart word. But, so, positive 1 or negative 1?
Negative 1.
Negative 1 because it has to bring back from the 6x that we'll make, it has to bring us back to 5x. That's the correct answer.
I did.
Does not work. You can't get your 5x that way. You cannot make your 5x that way. The dimensions would be wrong.
But it works in my area.
It doesn't work. What'd you just tell me you had? You had 2x. You guys can go ahead and start packing up minus 3.
Yeah.
X plus 1.
It works in my area. Mom.
So check out the outer inner. That's 2x. Minus 3x would make your combined sum negative 1x. You have another mistake somewhere. So track it back if you want, but you've got another mistake somewhere.
Mr. Hudson, can I have taffy?
No, not just because. No.
Oh, because it's getting
Oh, why didn't you get it? Oh, yeah, whoever left quickly, sorry, I forgot about that. Thank you for reminding me. Whoever left quickly, if you did not get a piece of taffy from yesterday, you can get one. If you have braces and can't eat it, I have suckers or other alternatives.
I can step on
No, I can still eat it.
Oh, right, yeah.
Yeah, a couple.
But you only get a couple?
Suckers, yeah, not
A couple?
taffy is a hotter commodity than suckers. And that taffy is a